very last speaker, we have somebody very, very special. I'm really happy to have her with me up on stage tonight. We have the regular GDG speaker, Ayesha, who is a computer science student at Melbourne University at the moment. And she is extremely passionate about machine learning and machine learning ethics, which is obviously a very important area to be interested in given some of the directions we're moving at the moment. I've mentioned that she's also a regular GDG speaker. She presented at our Christmas party with GoKids. She presented just last month talking about ML and TensorFlow. And I'm super happy to have her here tonight to present on machine learning. What's your AI? Please everybody give a huge round of applause to Ayesha.
So I hope you guys can see me because I get told that I'm not seen behind microphones. So thank you so much for the wonderful introduction, Luke. Machine learning is definitely something that's incredibly interesting to me, both from a philosophical perspective, but also from a technological perspective. From a philosophical perspective, because it really interests me to ask the question that, can we actually decode the black box that is human intelligence? Because the brain is literally one of the most complex things that we know about. And we've only touched 0.02% of how it works. And the idea that, oh, if we understand how intelligence works, can we also replicate it in a machine? And if we can do that with the resources we have in hand right now, what else can we do? So those types of questions are something that's really, really interesting to me. But of course, like many other types of technological research, machine learning and AI do come with their own caveats. And one of them is probably something that you guys are familiar with, which is bias. Now I'm actually going to tell you a short story about how bias can actually affect the way people interact with technology and how it can leave out people that are usually underrepresented in technology. So a few years ago, a computer science student at Georgia Tech University was working on a really cool project, a social robot that could interact with human beings. Except when she tried to get that robot to detect her face, it wouldn't detect her face. And that was a really weird situation because it worked perfectly on her project mates. It worked perfectly on her supervisor, so why wasn't it detecting her? And she looked at everything. She looked at the math, she looked at the code, she looked at the tech behind it. She asked everybody who worked on that algorithm, that facial recognition algorithm, if there was anything wrong with it, and nothing seemed to be quite out of the box. But then something hit her. The fact that the people that created that facial recognition algorithm happened to be mainly fair-skinned people, and she was a dark-skinned person. And because that algorithm was majorly trained on fair-skinned people, it learned that people that were majorly in that data set, of course, were the norm. And obviously, if you look at this data set, you can notice that there's literally just one dark-skinned person, and when you amplify that data set, it leaves out people that aren't part of the norm within that data set, and people that aren't in that data set are regarded as being an outlier. And obviously, that really affects the way certain people interact with technology, and can leave out certain people from actually even being able to use that technology, let alone being able to contribute to it. And the reason that this is a particularly prominent problem is the fact that machines don't even remotely think like us yet. Like for example, if you look at this picture of a cat, to you, it's just a cat, right? But not to a machine. To a machine, it's just a random bunch of bits that happen to accumulate in a certain way to form a pattern that is labeled a cat. They don't have any high-level understanding of what a cat is. They don't have any context understanding. And because of that situation, the reasons why machine learning algorithms make decisions are a black box. We don't know why machines make certain decisions because these algorithms are already so complicated. It's basically impossible to look at how it's working on certain ideas and why it happens to predict that outcome. But that's exactly something that Google was working on, which is TCAV. I promised myself that I would have what it stood for in front of me, but I forgot. It stood for, wait, what was it? testing for concept activation vectors. Yes, I remembered. So essentially, it allows you to peer into why a machine algorithm makes a decision. So for example, current machine algorithms will tell you that yes, this is a person, but why is this a person? So it will tell you the significance of the parameters that it picked to make that decision of saying why it's a person. So these are just a really, these are just an example significances I made up just to demonstrate to you how TCAB actually works. So it essentially clarifies to you how decisions are made on a pretty high level, so that if biases ever do occur, you kind of do have a direction to look in where your data set might be biased. So I think that's a really, really cool feature, because for the longest time, machine learning algorithms have been basically entirely a black box. And while this doesn't entirely make it a white box, it still is a step in the right direction into mitigating algorithmic bias. So other features that I also wanted to talk about were MLKit. So MLKit, as most of you probably know, are an SDK to allow machine tools to be used on your Android and iOS apps. And shout out to my friend who is featured on this. Can we have a round of applause for my friend? So one of the features that you can do now is actually have live voice-to-text on your videos. And that's not just on YouTube videos now, but you can actually have that on any type of video. So whether you're video calling your friend to compliment his red lipstick, or whether you're watching a lecture online that doesn't have captions, you can actually convert voice to text in real time. And another really cool feature that you can do is track objects in real time. So you can actually pair that tracking, image recognition tracking to, for example, if a business has a list of items that they're selling, you can incorporate that into your app. And in this example, I just used this picture of a plant. And you can take a picture of the item you're looking for, and it will just retrieve information about it, like the price, the type, other information that you would want to mention, like how much water it needs, whether it needs a lot of sunshine, etc. Other really cool features that came out as part of MLKit is Cloud AutoML. They added a bit more infrastructure and usability so that more users could use it. And the two really big parts of Cloud AutoML that changed recently were the fact that you don't have to write a single line of code in order to make a model, and the structure for your data isn't as strict as it was before. So you could just put a bunch of labeled data into a CSV file or a table format, and it'll generate a model just based off of that, and essentially just create a world-class model. Other really cool things were video intelligence. Now, this is a really cool thing because now it allows you to actually label each frame of every video. So now users don't look for the title of your video, but rather the content of your video and what's actually happening, because you're labeling the video frame by frame. But the thing is, both of these features before are pretty infrastructure heavy. And another really cool thing that's happening is the fact that you can actually train your data on Google's hardware. And this is still in beta mode, and it's also not something that's particularly new. This kind of idea has been done before, like sourcing hardware, but it's a step in the right direction into democratizing AI, into allowing people to make really heavy models. But these are both technological advancements, but in terms of research, how are we actually going about? And I'm really excited that there has been some more advancement done in how deep learning actually happens. And if you came to my talk before, I actually talked about how machine learning isn't just one static way machines learn. There are many different approaches to the way machines learn. And as I mentioned right now, the way machines learn right now is by taking very minuscule ideas at a very low level and trying to turn that into a label. But Google has kind of made some improvements in how we could actually improve that type of recognition. And one of the facts being that, what if we could collectivize the experience that models have into each individual model? Now, if that doesn't make sense, I'll just give an example. So let's say that you have at a factory, and you're trying to get each robotic arm to detect objects, and you're trying to get them to put them into baskets. Now, because all of these robotic arms are working on the same idea, what if we could get all of the experiences from all of those robotic arms and give them to each robotic arm so that they don't train only on their own experiences, but the experiences of other robotic arms as well. And this has actually shown some significant increases in recognition accuracy. Another really cool advancement in the research of deep learning is automatic rerouting. So the way humans recognize things, we don't use all parts of our brain at the same time to recognize something. Like for example, it's your cerebellum that keeps you coordinated, keeps your movements coordinated. It's not every part of your brain that keeps you coordinated. And that's why we don't use that much energy as much as we would if we use all parts of our brain at the same time to do one activity. And the question became, what if we could get that concept into deep learning algorithms? And that's essentially what automatic rerouting is. When we're trying to do one task of a particular deep learning algorithm, how do we coordinate the infrastructure into using just one part of that deep learning algorithm so that we have lower latency, but at the same time also lower energy usage? And this drastically reduces energy usage. And yeah, that's essentially what automatic rerouting is. I hope that makes sense. So just to recap, so far Google has been addressing inclusivity and diversity within their technology, which I think is a really important part of being able to advance and being able to contribute to important parts of technology. So far, it's also been addressing engagement and flexibility and reducing the barriers required to actually engage with these technology. As with CloudML, you no longer need any code to actually create world-class algorithms. And also, in terms of research, we're also exploring how do we improve the methods with which computers can learn through better mathematics, but also being able to get those algorithms to work on a very large scale. Yeah, thank you. If you have any questions, feel free. I think we're running short on time, so like.
Oh, that's okay. We've got time for a few audience questions. So,
okay,
any
yeah.
questions?
Yeah.